algorithm. Let's go ahead and first we look at the theoretical framework, then application to a function, then we'll go to the plotted results, and then the conclusion. So this gradient descent is is a method where we'll find the minimum of the function, and here we'll take the example of x square plus 5y square. This can be a data set as well. So, and we'll start with a initial point that is 12.5 and 12.5 x naught and y naught, and then we'll find a slope of this function at any given point, and then we'll go find the gradient there, which is given by this formula in equation 2. And after this we'll go along the direction of this gradient in a line, and for that single line the variable will be h, and then we'll keep on iteratively calculating slopes along the points as we go on, and then we'll march along these slopes one after the other and reach the minima, which is what we desire. So for this purpose, let's define this function, which is a vector function, this RH, and this is the vector form of the point that we've taken, minus this h, since we need a line now along the gradient descent, and this is the gradient. And then we define also another function which will take the points found out by this point, and it will plug in into this function. Let's see how we apply that in the next slide. So we will plug in this equation number 2 in equation number 3, and after this we'll get this RH here, and then we'll put this RH in the original function, which is the equation number 1, and we'll get this th function. So for a stationary point, to find the minima, we'll equate this function equal to 0, and we'll differentiate with respect to h, and with that we'll find h, and in terms of the point at which we have found the gradient, and then we'll keep on calculating, and first we'll do it for the initial point, and then we'll go on calculating it from points obtained thereafter iteratively. And with this, as you can see, as we go on in calculating these things, the points one after the other, the value will go on to the reaching the minima, and that's how the calculations will be done. So here you can see I've this contour plot is x square plus 5y square, and this is, and as you can see, the minima is at 0, and this is where we 12.5 plus 12.5 where we started, then we went along this line, then we went along this line, then you can see the algorithm ultimately reaches this minima. Now let's go to the program. We'll see the C program of this, and then we'll plot it in Python. So these are just the header files. So this is how we'll run it in Linux. So here this is for evaluation of time, and this is the number of iteration steps, and these are for writing the files for various variables that will be needed. So this n steps is the number iteration steps. So how many iteration steps are we taking that we'll write? Here we've taken 50, and we've drawn the graph for 7 only. You can choose accordingly and modify this code. Then so this is how I write that on the hard disk, then we'll read there. And then these are the x coordinates, array of x coordinates at which the gradients will be calculated successively. So we'll as the number of it will be as many as the number of steps are there. So this is how that will be found out. Then this is the initial guess. Here we have taken 12.5 and 12.5. One can modify this, and this is for printing the number of iteration steps. Then this is for writing the initial guess, and this is for writing the initial guess of y. Then this is for printing the initial guess. This is again for printing the initial guess in the y direction. This is that h variable as in equation 3 of the presentation. There you go, this one. And then this is that formula that we have implemented. See this one, this formula is being implemented here. Then we're going to print those h values, and this is inside the loop. Remember, as it runs, these are the iterations and steps. These are the iteration steps, and that we're going to save the successive values of these. Initially, we'll start with 12.5, 12.5 here. Then we'll go on updating them, and this is how we'll update them as per the formulas. This is, you can see. Where is it? Yeah, this is 1 minus 2h and 1 minus 10h, and this is how they are updated. Yeah, the equation number 6. So, and then this will give the ultimate minimum value for the given number of iterations, and this is printing that this is storing this minimum value. Then we'll print the number of iterations again. Then we'll print the x coordinate, final x coordinates. Then we'll print the final y coordinates. Then we'll print the minimum value. Then we'll take those array of those points for plotting the descent line, steepest descent line, and then in x coordinates here, then the y coordinates. And the Python program will read it, and then we'll calculate the time that was taken. Let's run this program. So here you can see it has run for 50 steps, and this is the result it is giving. So you can see that finally at the origin it has the minimum value is 0. Now we'll plot it in Python. So we'll run the Python code, and so there you go. This is what the Python code gives you, that steepest descent curve which I've put. So this is the Python program. So these are the libraries that we need in Python, or packages. This is for calculation of time and steps as we've written them on the hard disk. Then this will read it, load text. This will again read the x initial guess. This will read the y coordinate of the initial guess. I've written them on to desktop. You can use it in any other location. Then this will be an x. The array x in converted to integer. Then we'll define the range of test function here in x direction. Then define the range of x in y direction, and then we'll plot that function x square plus 5y square. There you can see these are the xy vectors that we've used, and these are written in a linear row major format, and when we can reshape them to two-dimensional. For some applications, linearized arrays are useful. One can do them in two-dimensional as well. I have taken row major format. Then we plot the contour and color bar, and then this is for reading those set of x coordinates. Then this is for reading the set of y coordinates for the steepest descent line, that red one that we calculated, and these are for legends and everything. So to get these final results, so like this. Yep. So this is the steepest descent algorithm. we'll go with many other conjugate gradient and many other algorithms, and we'll also do some work on neural networks, and this steepest descent is useful for neural networks and AI applications. So that's it. I hope you like the video. Please like and subscribe. Thank you.